In this video, we take a look at fitting polynomials to data given to us from a real-life situation, and we are going to use matrices to find the polynomial of best fit to this data. Here's a scenario that we are given. Conservationists and biologists are tracking the count of plant species in a forest that burned 12 years ago. The table shows the results of their research. Find and solve a system of equations to fit the data to a polynomial function. So our year started 2011, so we are going to let 2011 correspond with year 0 in our data. We don't want to go back to the beginning of the calendar. So we are going to say somewhere here that X is the year since 2011. So that 2011 is our year 0. So you can see here, I've written the points out as 032, 349, because 2014 is 3 years later, 654, and 8100. So we have 4 data points here, so we are going to be modeling this with a third-degree polynomial. So our polynomial, which we'll call P of X, is going to take on the form of some initial value. We're going to call it A sub 0, where this is the initial value coefficient. It'll be the constant in our equation, plus our next coefficient is A1 times X. Our next coefficient is A2 times X squared. And then because this is a third-degree polynomial, our last term is some coefficient A3 times x to the third power. Okay, so we are going to use this polynomial and plug in our different x values that were given and our solutions to come up with a system of polynomials so that we can work backwards to solve for our unknown coefficients. All right, I'm going to plug in 0 here is x. I'm going to call this first polynomial at 0. And so that's going to be a naught plus, well, 0 times a naught because x, or 0 times a1 because x is 0, plus, well, 0 squared times a2. I'm putting the x values before the unknown coefficients. You'll see that that'll give us things in the number times the coefficient that's unknown to us form. And then this would be 0 to the third power times a3. Now our next x value is 3, so we're going to call this polynomial p of 3. And that form is going to be a naught plus 3a1 plus 9a2 because 3 squared is 9. And then this will be plus 27a3 because we know if x is 3, 3 to the third power is 27 in this last term. Our next polynomial, p of 6, is a naught plus 6a1 plus 36a2 plus 216a3. And that 216 comes from 6 to the third power. You can double check that on your calculator or Google. And then our last polynomial is p of 8. And so we have a naught plus 8a1 plus 64a2 because that 8 squared gives us 64. And then 8 to the third power, I have to look this one up, is 512a3. If you do a lot of computing, you remember the powers of 2, so you might be able to remember that 512. But I double checked it just by typing 8 to the third power, 8 caret 3 in Google. Okay, so we are going to form a matrix now to correspond with this. We're going to augment our matrix with the solution vector. So if you just wanted to write the coefficient matrix followed by the column vector, it would look like this. All ones for the a sub 0. And then we have 0, 3, 6, 8. Then we'd have 0, 9, 36, 64, the squares. And then we'd have 0, 27, 216, and 512, the cubes. And so this would be your coefficient matrix, and you put our solution values, the outputs in those points that we had as 32, 49, 54, and 100. that these values are coming from the outputs that plant species counts from the initial 4 points that we had there. We're going to go ahead and work with the augmented matrix. So in the next slide, I'm going to take our coefficient matrix over here, which is a 4x4 matrix, and combine it with our column vector of solutions there, so that we will have a 4x5 matrix. I'm going to call that matrix M. So I am recopying my matrix, and then I'm going to augment it with the solutions. And I'm just going slow so I don't make a typo, which is easy to do when you're writing on the computer whiteboard and talking at the same time. All right, so now I'm augmenting my matrix with my solutions. In the last column. All right, so this is a 4x5 matrix because it has 4 rows and 5 columns, and we call it the augmented matrix. And because this matrix has that 5th column of solution values, we are able to simplify this matrix and put it in reduced row echelon form. I am not going to do that by hand, so we're going to head over to Simply Live and let the technology do these calculations for us. So over here in this tab, I've got Simply Live, so I do have to input my matrix. So I'm going to call my matrix M again. I like that letter for it. So I'm going to say here M equals, I'm going to call it a capital M. I think you could use lowercase if you prefer. You do need to use a capital M here for the matrix function. And then in parentheses, we're going to put our values here. Then we use brackets, and each bracket corresponds with a row in the matrix. So my first row is 1, 0, 0, 0, 3, 2. And you pull down a little too far. And then we'll close off that row, put a comma, and then put our next row in there. And the next row is 1, 3, 9, 27, and 49. Our next row in brackets is 1, 6, 36, 216, and 54. And then our last row here is 1, 8, 64, 512, and 100. And it's okay if you make a mistake, you can hit that space. If you hit enter and make a mistake, Simply will tell you your error message. So I need to close off my matrix with single bracket and then parentheses. So if I hit enter, it looks like it accepts my matrix okay. I can check by typing M, and here pops up my matrix. And that looks just like the matrix that I calculated with the polynomial equations. So now here comes the magic of technology, is I want to get my reduced row echelon form here. So I'm going to type M, capital M, because that's what I need my matrix, dot RREF. And then I'm going to put the parentheses here so it does the reduced row echelon function. And then I just want the first output. Remember, if we don't put this, we get the pivot column as well, the pivot column location. So we are just going to put a 0 in here in a brackets. That's kind of computer code speak for just give me the first column in the values that this function returns. And we hit enter, and here's my matrix in reduced row echelon form. So what this is telling me is that in that first row, my coefficient that we are calling a sub 0 is 32. My coefficient in the second row that we are calling a sub 1, that's going to multiply by the x, is this fraction 563 over 30. My coefficient A2 is negative 373 over 60. And my coefficient A3 is 37 over 60. So these are not the nicest values because we're working with real data, but that's okay. And we are going to head back into our Jamboard here in Google, our whiteboard. and write down our polynomial. So our polynomial that models this data is P of X equals 32 plus 563 over 30 times X minus 373 over 60 times X squared and plus 37 over 60, my 37 doesn't look so great here, times X cubed. All right, now if we want to plot this, I can do that in Simpy, so I'm going to head over to Simpy Live and do a plot to see how it looks. Okay, so I first need to import some libraries with plotting. So I am going to import symbols. So I type from Simpy import symbols, all lowercase. And then I'm going to import the plotting function. And I'm erroring up because I previously typed all this in to save some time here. So the next command I put in is from simpy.plotting import plot. And so these are libraries I'm bringing in to do the plotting for me. And then I want to let X be a symbol now, not a letter or character. So I am going to type X equals symbols, and then in parentheses and in the quotes, I put the X. So that's going to be my input in my polynomial. All right, next I'm going to plot my polynomial. So I'm going to say here P1 equals plot, and that plot command comes from the Simpy plotting library I've imported. And then I'm going to do 32 plus, and then my first coefficient was 563 over 30. And then to multiply that by X, I use a star here, and then I subtract my next coefficient. To get the exponent 2 after the X, I did double stars. It's the code in Simpy to get the exponent. So if you do the caret, you'll get an error. And then I add my last coefficient, 37 over 60, multiplied by X to the third power. And this should give me a pretty basic plot here. Let me scroll up so you can see it a bit better. So here in my plot, I got kind of like a dot plot, but I can see that rough cubic shape. And we will see later on how you can more precisely graph with Simpy and control the X values and the range of use alike. But we see, okay, here's our rough cubic shape modeling this data.